We're going to learn about the inscribed angle property in this video. The inscribed angle property states that in a circle, all inscribed angles subtended by the same arc are congruent or exactly the same. So if they're inscribed angles, which means that they touch all 3 points on the sides of the circle, and they all subtend the same arc, like in this case, these angles all go to that arc, that they are congruent or exactly the same measure. So let's look at some examples here. This inscribed angle right here is 40 degrees. This inscribed angle right here goes to the exact same part of the circle or subtends the same arc. So it also has to be 40 degrees. Okay, this example here, angle Z and this angle right here both subtend this arc. So Z has to be 42 degrees. If I go the other way, angle Y and this angle right here both subtend this arc. So Y is 27 degrees, the same as that measure. One of the implications of this one is that all inscribed angles subtended by a semicircle are right angles. So this one here is 180 degrees. It's a straight angle. All angles that subtend that have to be half of that, which is 90 degrees. So if I look down here at this example, I have my diameter here, which is 180 degrees. That means this angle right here has to be 90 degrees because it subtends that. Also, this angle right here has to be 90 degrees because it subtends that arc. So let's do some examples of where we can use this. So we're finding Z and Y here. Given this angle right here, it subtends this arc right here. Z also subtends that same arc, so it's 70. Now going back to my central angle property, Y here has to be double the inscribed angles, so Y would be 140 degrees. If I look at this next example, I notice this is a straight angle or a diameter. I'm trying to find Z, so if that's a straight angle, then 50 degrees is that. This would have to be 130 degrees because a straight angle adds up to 180 degrees. Now, if that's 130 degrees, you notice this is an isosceles triangle right here. So to find Y, this angle and this angle would have to be the same, and they'd have to be 50 together. So half of that would be 25 degrees. Okay, it would be a good idea to pause the video and take down some of these if you don't remember them. Some basic properties that you need to remember. So properties of triangles, all angles add up to 180 degrees. An isosceles triangle is where two angles are the same and two sides are the same length as well. Equilateral triangle, all angles are 60 degrees. Properties of a quadrilateral, all angles add up to 360 degrees. This is a new one. Opposite angles in a cyclic quadrilateral add up to 180 degrees. In a cyclic quadrilateral, all corners touch the side of the circle. So let's do an example of that. This right here is a cyclic quadrilateral because all corners touch the outside of the circle. Now, when we're trying to find the angles on this one, that's my diameter. That's 180 degrees. So I know that that has to be 90 degrees. If this is 90 degrees, that's 50 degrees. To add up to 180, y would have to be 40 degrees. Okay, on the top part, I know that that's a 90-degree angle because it also subtends the same arc. This is an isosceles triangle. That means that this angle and x have to be the same thing. Well, if that's 90, that means that this one and this one would also have to add up to 90. And if they have to be the same, they would both be 45 degrees. Okay, down here, I have 80 degrees as my central angle. Going back to my first property, that means x would have to be half of that, which is 40 degrees because they both subtend this arc. Okay, if that's 40 degrees, this is an isosceles triangle. That means y would also have to be 40 degrees. Last example in this video. So to find y, I would have to look at this entire circle. A circle in a complete revolution is 360 degrees. So if I go 360, subtract 116, subtract 128, that's going to give me what that angle is right there. So what that ends up being is 116 degrees as well. So y is 116 degrees. Now x is a little bit more tricky. X is this angle right here. I need to notice that since these are radius, that's going to create an isosceles triangle. So that angle and that angle would have to be equal. So in this triangle right here, that adds up to 180 degrees, I'm going to find out what x is. So I'm going to go 180 minus 116. So that gives me 64 degrees for both of them. Divide by 2 is 32 degrees for x. So x equals 32 degrees.